So yesterday we had completed one numerical regarding the KNN, and we solved this numerical in which we had to determine that what would be the classification for x1 equal to 3 and x2 equal to 7 based on the data given. And we solved with all the 4 steps. We did the uh, prediction as good based on what we did in all the steps. So these are the advantages of KNN. We stopped at this. So the advantages of KNN, k nearest neighbor, is that first advantage is that the prediction quality. So prediction quality in this KNN, it is generally good in a way that it can go through the data which has, I mean, generally which would not have been done in by the other uh, models. When we say that it is a outlier or anything, we have different issues for different algorithms. But for KNN, it is able to recover the unstructured partitions. So whenever there is no structure, then also KNN is very helpful. And SVM we will be studying in the coming lectures. But in SVM also, compared to SVM, KNN is good in some of the non-linear predictions. And the another advantage is because there is no training involved, so it is very fast uh, compared to the other models where training is involved. In this we do not need any kind of training, so this is one of the advantage. Short cycles, this means that iterating over the different possible metrics or modifications of the data set is potentially faster when compared to classifier, which requires a heavy training procedure. So because training is not required, that's why we can quickly get the results. uh, so multi-class classification, this point says that we can handle large number of classes. Generally, when the number of classes increase in our classification, then complexity of the model also increases. But for KNN, because we are not doing any kind of training, we are just classifying our model into different classes based on the distance metric, and we are sorting and everything. So based on the k value, we are taking the uh, top points which are closest to us, and we are taking the call about the classification of the class. So the fourth point of the advantage is that interpretability. So generally, when we say that uh, so when we say that your model is giving a class of 1 or maybe 2, so in KNN you can actually visualize it that okay, yes, it is near to class 1 or it is near to class 2. So you can have a better interpretability, a better explainability, right? So the prediction is based on the similarity of existing objects. Depending on the shortest distance, you can say that it is the closest one, that's why you are class X. So whatever the interpretability is, it is easily understood. So there are some limitations also for our KNN algorithm, and it is costly because obviously we are saving full training data. Actually we don't have any training or testing, but yes, we are at all times we are keeping all the points in our memory. So because we are keeping all the points in memory and we are also checking the distance every time, so it is very costly. So for a dimension, for n data points of d dimensions, the complexity is OND, uh, according to the arithmetic operations per query, and OND memory is being used. So this is the high complexity and it will be very costly to implement. So the so when we want to reduce the cost, so this is one of the cost that this is one of the limitation, that it is very costly. Now how can we reduce that cost? One of the method is subsampling. Let's say that we have 10 million data points. Let's say that we randomly select 1 lakh points out of those 10 lakh points. So based on those 1 lakh points also, we can make the similar kind of prediction uh, which we would have made for the 10 million points. So 10 million is equal to 1 crore. So compared to 1 crore, 1 lakh points are 1% only. So just using the 1 lakh points out of 1 crore points, we can say that still our answer will be fine because we are randomly keeping all the points of all the classes the data should be there. So this kind of subsampling helps us to reduce the cost, because we are not saving the 1 crore points now. We are not saving 10 million points. We are actually saving only 1% of it. So space is saved. And then that dimension reduction. So if you apply L2 and cosine distance, so it's possible to reduce the dimension of the data points while maintaining the distance between query point and data point. For these distances, it is possible to reduce the dimension, uh, and these distances works fine even if your dimension is less compared to the original data set. And the quality of the approximation depends on the dimension of the output. So whatever the output dimension is, your approximation will be based on that. So these two distance techniques helps us to even work on the reduced dimensions, and the answer is not much affected. So small dimensions means a crude approximation. Crude approximation means that you will not be very precise, but you can make a kind of approximation for the particular class, and yet it is often the case that we can obtain a good enough approximation for the distances while reducing the dimension. So generally, basic thing discussed here is that by using these two distances, if the question comes that how can you reduce the inference cost for the KNN using the dimensionality reduction, you can say that these are the two distance uh, techniques, L2 and cosine distance, which helps us to get the crude approximation even with the reduced dimensions. And the last point is that you can avoiding the regions quickly. It means that when we want to, let's say, do the prediction of this green point, we will actually get the centroid, or the center point of the two clusters. Let's say this was my cluster 1, this one was my cluster 2, and getting the midpoints, these red points are the midpoints of these clusters. We will directly check the distance of green point from the red points. So clearly this left hand side is away, so we can say that this cluster will not be correct for us, and this one will be close. So maybe this green dot belongs to the second cluster on the right hand side. So avoiding regions quickly means that a common approach for disqualifying data points quickly is through clustering. If the center of cluster is far away, so that's what I have already said, that when the cluster is far away, let's say we are comparing two clusters, so whichever is far away, it will be rejected, and you can keep the second one. So this is how you can reduce the inference cost for KNN. That's all for KNN. These were the limitations, these were the techniques to reduce the inference, and these were the advantages. And rest of the slide we have already covered in yesterday's class. So KNN is over. So we have also completed the KNN now, and we will be starting the decision tree classifier. Decision tree has multiple types of algorithms, and we will be discussing all of them one by one. Mainly we will be discussing three types of decision trees. ID3 is one of the decision tree algorithm. So let's see what does this mean. So for a decision tree classifier, uh, first of all we should know that it is a supervised learning algorithm, and it is a distribution free or non-parametric method which does not depend upon the probability distribution assumptions. So we don't have any kind of distributions in this. We don't have much parameters also, and it does not depend on any probability distribution the way it was depending on the previous models. So decision trees are one of the most important concepts in the modern machine learning. Not only that they're effective approach for classification regression, but they are also the building block of models like random forest, gradient boosting. These are very famous models. So we will be discussing these models also. But for now, let's focus on the basic decision tree. So decision tree can handle high dimensional data with good amount of accuracy by constructing the internal decision making logic. So what happens is we are generating a tree using the data, and we are making the decision based on that tree. And decision tree is a flowchart like tree structure where internal nodes uh, represent the features or the attributes represented as a square. So all the features of the data set are part as the internal node. The branch represents a decision rule. Whatever the decision rule is, that will be the branch, and leaf will be the outcome, and it is represented by the ovals. So whatever the class output is, or whatever the output is, we will be representing it as a leaf node in shape of ovals, and all the internal features will be represented in a square. So conceptually, decision trees are quite simple. We split a dataset into smaller and smaller groups, attempting to make each one as pure or homogeneous as possible. So in this dataset, we mean that we are trying to split a dataset into smaller groups. We are making very small groups, and uh, so as to make the pure or homogeneous. Uh, very small groups are pure or homogeneous. So all the classes in that group are of the I mean they all belong to the same class, so that's pure or homogeneous. So once we finish splitting, we use the final groups to make predictions on the unseen data. So when the splitting is done, because we are making multiple splits, so in the end the prediction should be done easily on the even on the unseen data. You can see here all the internal nodes, the decision nodes are in a I mean in this you can see it is a rectangle, but theoretically it should be a square. So decision node are the internal nodes, and leaf nodes are in oval shape. So let's say that on the right hand side, this is example. If the salary is between 50,000 and $80,000, so if it is yes, and you have to make a decision about accept or reject the job offer. So you have to see multiple things in which the salary is also there, this distance of the office, and the cab facility if it is there or not. So based on all the things, we have made a decision that if salary is not between 50,000 and 80,000, we will decline the offer. If it is between that, we will also see that if office is near home, then we will move ahead and check for the cab facility. If the cab facility is also there, then we are accepting the offer. So clearly all the three conditions are true, then only we are accepting the offer. Even if one of the condition is false, we are declining the offer. So this kind of a tree can help us make the decision, and that's how the basic decision tree works. So I mean here are yellow boxes, all are the internal nodes, and the final decision is decline or accept. So this is a binary decision tree. I mean in terms of binary class, so it is a decision tree with two outputs, accept or reject the offer. So now there are multiple variants of decision tree. Mainly they are ID3, CART, C4.5. There are other models also, but these three are very famous, and we will be discussing them one by one. Today we will be discussing the ID3 method. Then we will be discussing about the CART and C4.5 in the coming lectures. So variants of decision tree classifier. So a successful decision tree is one that does a good job of splitting. So you have to split the data into homogeneous groups. So you have to make the groups in a way that similar classes are in the same group. Therefore, in order to build a good decision tree algorithm, we will need a method for evaluating splits. There are several different uh, so there is this repetition. There are several different algorithms used to generate trees, such as these three: ID3, CART, and C4.5. For this ID3, we can say we will be making the decision, making the use of information gain to decide the partition feature. So we will be using this information gain feature to make the decision, and not designed to deal with the continuous features. So generally ID3 is only for uh, what we say classification, not for regression. And for CART model, we will be using the Gini coefficient to decide the partition, and it can be used for both the classes classification and the regression. C4.5 will work similar to information gain by using information gain, and you will be splitting that data. However, your C4.5 can handle the continuous features, and also it can handle the missing data. So here there can be a simple question that can be formed, that which model can be used for classification as well as regression. Obviously, it means that you will be using I mean, you can say that it can be cart or C4.5, but then if you are asked that which one will be, which one can do classification regression and also it can handle the missing data, so answer will be C4.5. And if you are just asked about classification and regression using the Gini coefficient, then the answer will be cart. And if you are asked that you will be using information gain to make the decision, and which one will it be, it will be ID3. So we will look into the ID3 in detail now. ID3 means that iterative dichotomizer 3 algorithm. This is the full form, and it is named such because the algorithm iteratively dichotomizes. Dichotomizes means divides the features into two or more groups at each step. So it was invented by Ross Kunlen. ID3 uses a top-down greedy approach to build a decision tree, and in simple words, the top-down approach means that we will be starting to build the tree from the top, and greedy approach means that for each iteration we will be selecting the best feature at the present. I mean, we will be making the decision based on information gain. So because information gain was the main criteria, right, to decide the partitioning. So whichever feature will be having the maximum information gain, we will be using that feature to do the split. So ID3 generates a tree by considering the whole set S as the root node, and it then iterates on every attribute and split the data into fragments known as subsets uh, to calculate the entropy or the information gain of that attribute. So we will be doing the split, but for each attribute we will also be looking at the information gain value. We will be coming to the formulas in a while. After splitting, the algorithm recourses on every subset by taking those attributes which were not taken before into the iterated ones, and the best feature is selected using the information gain metric. So I'm saying it again that this entropy and information gain, these are the two metrics in this. I mean, information gain is calculated, but then before that you have to also calculate the entropy. That's why entropy keyword has also come here. So entropy and information gain will be the main criteria to decide that how do we split. So let's see what is entropy first. So it is defined as a measure of impurity present in the data. So we impurity in data means that how much dissimilar the classes are between the same group. So entropy calculates the homogeneity of a sample. So in this, what's happening is if the sample is completely homogeneous, the entropy is zero. So if all the classes are same, of all the samples have the same class in the group, so the entropy will be zero. And if the sample is equally divided, it has entropy as one. So let's say that there is a group of four elements in which two are of the positive class, two are of the negative class, then your entropy will be one, because you are dividing 50-50 data, right? And as shown in the binary class, so you can see here in the diagram that entropy formula is minus p log 2p minus q log 2q. So let's see, entropy with the lowest value makes a model better in terms of prediction as it segregates the classes better. So based on the probability, the entropy curve has been made. And so if the data set is divided in 50-50, right? So let's say that 50% is of the class p, so 50% is of class q. So this formula will have these values, minus of zero point 0.5 log 2.5 minus this. So if you solve this equation, the answer will be coming out to be 1, right? If you want the mathematics, it can be solved like this. One second, I will solve this equation for you so that you have a better understanding. So obviously when we say log 2 and zero point 0.5, zero point 0.5 means 1 by 2. So we can solve this as so yeah, I will solve this at the top, log 2.5. So what will be the value for this? It will be log of zero point 0.5 divided by log of 2, right? And log of zero point 0.5 means log 1 by 2, means log 1 minus log 2 divided by log 2, right? Log 1 is 0, and minus log 2 upon log 2 means minus 1. So it means that minus zero point 0.5 into minus 1 minus zero point 0.5 into minus 1. So it is coming out to be 0.5 plus 0.5 equal to 1. So that's why this 1 is there. I hope this equation is clear to you. This is how you calculate the entropy, and if the dataset is 50-50 for both the classes, it will be having the highest entropy. It will be 1, right? So if the probability is 0.5, entropy value is touching at the top point, which is equal to 1, right? So yeah, this is the formula. Minus of pi log 2 pi and summation for all the uh, values from I equal to 1 to n, where n is the total number of classes in the target column. So in case n is equal to 2 means yes or no, you have to see that what is the count. Based on that, you have to solve for this thing. The probability I of class I is the ratio of number of rows with class I in the target column divided by total number of columns. Obviously, let's say that there are total 5 rows, right? And for that, let's say the classes were 10101. So the probability of 1 is 3 by 5 here, and probability of 0 is 2 by 5 here. I hope it is clear, and that's what it is written here. Information gain. So how to calculate information gain? First we will understand what does it mean. So in a decision tree uh, building process, two important decisions are to be made. What is the best split? So what is the best split point? And then, and which is the best variable to split a node, right? So which is the best variable and how to split. So these are the two things. Information gain criteria helps in making these decisions. So we need to calculate the entropy of the parent and the child nodes. So when we are trying to solve this thing, we will be calculating the entropy for the parents and child for calculating the information gain due to the split. So the concept of information gain is based on this definition. The more we know about a topic, the less information you are apt to get about it. To be more concise, if you know an event is very probable, it is no surprise when it happens. That is, it gives us little information that it actually happened. So this is a self-explanatory sentence. It simply means that I mean, if you know the topic, then obviously very less new information will be there for you to gain. And if you don't know the topic, then you will be gaining more, right? So that's what is being talked about. The amount of information gained is inversely proportional to the probability of an event happening. So we also say that an entropy increases, the information gain decreases. So these are inversely proportional to each other. So when the entropy increases, the information gain decreases. This is because the entropy refers to the probability of an event. So if the probability is high, information gain will be low. So this is the formula. Information gain is equal to entropy of the parent minus sum of weighted percentage into entropy of child. So this is the formula. This is the final formula which we will be using to solve the information gain value, and we will be using this exact formula in the programming also. So here weighted percentage means that number of observations in the particular child divided by sum observations in all the child nodes. So this is the formula here. Here we have information gain for a feature column A. So this formula is valid for single column, right? So if you want to do it for multiple columns, let's say that there are multiple columns, column 1, column 2, column 3, column 4. So you will have to calculate the information gain 4 times, right? So you will be doing for IG1, IG2, so similarly up to IG4. So for all the columns you will be calculating, but for a particular column we can say S comma A formula will be entropy of S, where S is the set of rows. uh, so SV, let's see that what are the different variables here. There is S, there is SV, there is this S again, entropy of SV. So let's see that what are the different values, right? So first we will say that this S mod S is the number of rows in S. So when we say this S has to be calculated, the entropy, so it means that we have a data set. Here we have S number of rows. So this is the S, right? And for these S number of rows, you will be calculating the entropy. This will be the parent, and then minus of summation SV means that the set of rows in S for which the column A has a value of V. uh, I mean, to make it simplified, I would say it is being said that in this particular column, SV means that, let's say, class 1. So for class 1, how many rows are having value of 1? Let's say 70% are having 1 and 30% are having 0. So this value, this SV upon S will be equal to zero point 0.7, right? 70 upon 100, it will be zero point 0.7. And yeah, I mean, that's the basic idea. You will be calculating the entropy of the entire sample. You will be calculating the entropy of the rows having that particular type of class, and you will be putting all the values in this formula, and you will get the information gain. Information gain calculates the reduction in the entropy and measures how well a given feature separates or classifies the target classes. So the feature with the highest information gain is selected as the best one. So I said this earlier also, that whichever feature will have the highest amount of information gain, that will be selected as the splitting point, and that's how the decision will be made. Let's hear the pseudo code of the ID3 algorithm, right? So this algorithm has multiple steps you can see here. So let's discuss it one by one. So there are all the instances, there is a target attribute, and there are all the attributes. So instances means S, target attributes means whichever class you want to focus on, right? So it will be VI, and attributes will be uh, all the classes, right? So maybe summation, not summation, but all the V, all the type of V. So let's see. So create a new root node to the tree. So this is the first step. And if all the instances have the target attribute belonging to the same class, then the tree will be returning a single root node. So obviously, if all the rows have 1 1 1 1 1, so everyone is having one, so there is only one class, it means that you will be returning the tree with the single root node with the label C. So whatever the tree will be, you will be saying that okay, it has to belong to one. In case all the attributes are having value of same class C. If the attributes is empty, then you will be saying that it will again give the single root node, and the with the most common label of the target attribute in instances. So whichever will be the most common, the mode will be taken and it will be given as the output. Otherwise, the base all the steps that has to be followed are these. So first you have to say that A is the attributes in A the attribute in attributes which best classifies the instances. So we will be taking the target attribute. This was not A, this was not V, this is A. So target attribute will be one out of it, so it is A. Root decision attribute is A. And then for all the attributes, for now we will be seeing that for all the possible values Vi of A, so how whichever classes are there in A, for all of them one by one it will be checked for. Add a new ramification below root corresponding to the test of A equal to Vi. Let instances be the subset of instances with the value Vi. So I will be explaining this with an example, but for now you can just try to understand that what does this mean. So if instances Vi is empty, then below this ramification add a new leaf node with the most common value. So whichever will be the most common value, it will be put as the leaf node for the target value, if the instances is empty. And else below this ramification add a subtree. You will be have you will have to add a subtree. Again, you will have to call the same uh, algorithm in a recursion manner, and based on that subtree will be added, so that kind of split will be continuing to happen. So let's see this by an example. This will make many things clear. The algorithm will be very clear after this. So let's say that you have a data set in which you want to say, you have to so let's say it is not play tennis, it has to be golf. 1 second. Yeah, so it is again the golf problem. Again, if you see clearly, there are 5 no in this, 5 no are there, and 9 yes are there. And based on these values, we have to make the decision tree classifier ID3 that will classify any new test case given. right? So right now we are not given any test case, but we will have to make the decision tree this time. Using the ID3 algorithm, decision tree has to be made for all the values in front of you. So let's look into this. The entropy will be calculated in a way. I mean, there are 9 positive samples, there are 5 negative samples. So you putting the formula of the entropy, you get the value of 0.940. So this was the formula you have seen earlier, that entropy formula was this, minus of summation pi into log 2 pi. So if you put all the values in this one, base is log 2, right? Base is 2, and 9 by 14 log 2 9 by 14 minus 5 by 14 log 2 5 by 14. For solving these, I mean, after solving this, you will get a value of 0.94. Now we will be looking at one by one for all the columns. And first of all, we will be looking at outlook, right? So first, I mean, there are multiple columns here. First is outlook, second is temperature, third one is humidity, fourth one is windy. So I will solve for all the columns one by one, and we will see that whichever is having the maximum information gain value, that will be selected as the split node. So for the attribute of outlook, we are making the table here. So for outlook, having the value of sunny, play tennis is no 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 yes yes. For rainy, the values are yes yes no yes no. For outlook equal to overcast, the answer is yes 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 every time. So out of this, we can make a table here. We can say that for outlook equal to sunny, there are 2 yes and 3 no's. For rainy, we have 3 yes and 2 no's, and for overcast, 4 and 0. So I mean, after getting this p and n values for all the 3 types of classes in the outlook, 1 2 3 were the 3 classes, the entropy values have been calculated using the values of p and the values are 0.971, 0.971, and 0. So these are the 3 entropy values. So because now we have these 3 values, we can I mean, we can make the call that what will be the average information entropy. So for average information entropy, let's see that first of all how these entropy values have been calculated. So for outlook equal to sunny, the formula says 2 by 5 log 2 by 5 and 3 by 5 log 3 by 5. So these were the values, right? So first positive class, then negative class. So this is getting me the answer of 0.971. Similarly, rainy one is getting me 0.971, and the third one is getting me the answer of 0. So this is how the 3 entropy values have been calculated. Then the average information entropy will be, you have to multiply these entropy values, but using this ratio also you have to take care. So we know that for sunny, there are 2 plus 3, 2 plus 3 upon 9 plus 5, right? So total positive and total negative are 9 plus 5. So denominator will be 14 every time denominator is equal to 14. But in the numerator, 2 plus 3, 3 plus 2, and 4 plus 0, all the values have been taken from the table on right hand side. So these values have been taken and put in this formula, and the final average information entropy is coming out to be 0.693. And information gain formula says that you have to subtract the this average information entropy out of the total entropy. So total entropy was coming out to be 0.94. Average information entropy is coming out to be this one. So information gain is equal to 0.247 for outlook. And similarly, if you do it for temperature, now temperature has 3 classes again: hot, mild, and cool. And for all of them, we have made this table and we have calculated the entropies. Average entropy is coming out to be 0.911. So this information gain for temperature is coming out to be 0.029. Earlier it was 0.247, it is 0.029 this time. And third time, for humidity, we are calculating, my answer is coming out to be 0.152, and fourth time windy is coming out to be 0.048. So out of these 4 values, so this one is 0.048, so the previous one was 0.152, right? Before that it was 0.029, something like that. And here the first one temperature was 0.247. So this was 0.029. Yeah. So out of these 4, obviously the highest number is this one, first one, right? So obviously the first value having the outlook will be selected as the root node. So the root is outlook because outlook has the maximum information gain value. So now it will look like this for outlook. uh, I mean, after making this outlook as the root node, then you have to make decision that now what to do, right? So outlook has three values: sunny, overcast, and rain. So overcast, according to outlook equal to overcast in this data set, whenever this outlook equal to overcast came, every time my answer was yes, right? So every time answer is yes. So that's why we have made it directly that whenever your outlook equal to overcast comes, you will have to give the output of yes. So this is the final output for outlook equal to overcast. But what happens if outlook is equal to sunny or rain? So now we will solve it. For outlook equal to overcast, every time it was yes, so that's already done. Now we will be doing the splitting for sunny first, right? So let's see, if outlook is equal to sunny, this will be the table, and if outlook is equal to rainy, this will be the table. And based on this, now again you will have to find that which will be the splitting thing. So for outlook equal to sunny, the positive and negative are 2 and 3, and the entropy is coming out to be 0.971. And for all the different values, 0.571 is coming for temperature, 0.971 is coming out for humidity. So for all these three, the best one was coming out to be for humidity, right? So yeah, temperature is 0.571, humidity is 0.971, and wind is 0.02. Obviously 0.971 is the highest, so humidity will be selected. For sunny, you have to give the value of humidity, and based on that you have to make the decision after that. So for humidity, we will see that what is the case. So whenever the humidity came, one second, yeah, so whenever my humidity came, so there is this high value, right? There is this normal value. So high and normal are the two values there, and you have to make the decision based on that. Okay, so we were here. So if the value is normal humidity, then yes. If humidity is high, then no, you will not play golf. So this is kind of a normal thing, so for making the decision. And in fact it can be I mean checked here. For all the outlook equal to sunny, humidity having high or normal has the same answer as no or yes. So based on that, if all the values having the sunny and high combination, the answer will be no. So that's what is written here: sunny and high, the answer will be no. And similarly yes for the other case. And now you will be doing it for your second technique. So you will be doing it for now rainy. Yeah, sunny is done. Now we will have to do it for rainy. And for rainy, again my entropy is coming out to be for 9.971. And for temperature, the table is this one now. And using this table you will have the value of temperature as 0.20. For windy it is 0.971, and humidity it is 0.020. Obviously windy wins, right? So we will be making the decision call on windy. So if it is rainy, you will be taking the split through windy. And within windy, yeah, if it is rainy and the wind is there, if the wind is weak, the answer is yes, else the answer is no. So that's what is being shown here. If the windy is weak, the answer is yes, else the answer is no. So this is my final decision tree. I mean, it is a big thing to calculate all the steps. And uh, so there are lots of steps that we will be doing in this to solve this thing. To get this decision tree, we had to solve lots of stuff. First of all, we took all the four columns and we selected that okay, outlook was the root node. And then after that we made the decision that what has to be done for sunny, overcast, and rainy. For overcast it was simple, that every time overcast was there, yes was the answer. But for sunny, we again calculated which will be the root node, there the humidity one. And for rainy, windy one. and based on that the decision was made that if humidity is high you will not play golf, if humidity is low or maybe normal you will play golf, and similarly for windy weak you will play golf, windy equal to no you will not play golf. So this is how the final decision tree looks like after implementing the ID3 method using the entropy and the information gain. So there are some limitations of this method. ID3 can handle only the categorical values and not the continuous values. So it cannot handle continuous values. It is only for classification, not for regression. ID3 cannot handle the incomplete data. If there are missing values, it will again, it will not be able to handle, because I mean, we are very much dependent on calculating all the values every time we are making the decision based on the table only. We have to, I mean, we have to use all the values within the table. So if there are missing values, ID3 again cannot be used. ID3 algorithm is biased towards the feature which has the large number of distinct values. So this is due to the reason that feature is chosen on the basis of information gain. So we know that when we are calculating the information gain or the entropy, when there is high biasness or maybe there is a high count of same type of class, then that entropy is affected, right? And information gain will also be affected in that way. So that's why it is biased. ID3 is biased towards the feature which is having the large number of distinct values. And so if a feature has large number of distinct values, the reduction then reduction in entropy would be large. So this is these are the limitations. One of the limitation, the last one is overfitting. I think this is last one. Yeah. So overfitting is one of the limitation of ID3. So I mean, I will explain it through this one. So overfitting means that there is a difference between the training and the testing accuracies, or so if the accuracy and accuracy is error, accuracy or the error difference is large between the training and the test data, then it is called overfitting. So this is overfitting. You are able to get a good accuracy around 85% for the training data set, and for your testing data set you are getting around 65% accuracy. So let's read these points quickly. ID3 algorithm grows each branch of the tree just deeply enough to perfectly classify the training examples. So obviously when you are making different nodes and you're taking the decision which one to make the root node and then move ahead, so all those things have to be considered. I mean, it tries to make deep connections, but overall, when you are making lots of when you're making too much of calls and making the split every time, it may lead to very high, very complex decision tree, and it might lead to your model being overfit. Because let's say that there are multiple levels. So if your model is maybe very complex in a way that it is making call based on very complex splits. So if there are lots of splits in your data set, then obviously it means that kind of you are going through a lot of curves. You are moving through this side, you are moving through this side, and so you have to make decision every time that which side you have to go. This will lead to overfitting obviously, because you are having more options, and in this case when you have more options to go, then your model might not perform good on test data set. So this is the basic ideology behind overfitting. And you have to avoid the overfitting using the pruning. There are two types of pruning: pre-pruning and post-pruning. uh, so we can discuss this in the next lecture. I'm stopping the lecture at this point. We will be discussing that how to avoid overfitting in ID3 method in the next lecture. So that's all for today. I'm stopping the recording.